as VDS is increased above VGS minus VT for a saturated NMOS FET, we know, of course, we're going to be in saturation, so we're looking at the saturation region. So we're also going to look at something like this, right? Our VGS minus VT is going to be equal to our overdrive voltage. So as VDS is increased above this, we're going to look at what's going to happen. So the first one we'll come back to, we'll go from the bottom to the top. So looking at this and looking at what we have here, we have the channel becomes pinched off near the source. We can see that the channel is very wide near the source, so this is not true. The depletion region around the drain gets narrower. Well, if you look at our drain over here, the depletion region is actually getting larger. So this one is also not true. We also see the capacitance of the drain PN junction gets larger. Well, as our VDS is increased above here, for a saturated MOSFET, we know that the capacitance is the same. If we were to look all the way down here, it is not exactly the same, but it is proportional to the increase of our actual gate voltage. So it's proportional to that, meaning that if this becomes a flat line, it's not going to get larger. So the error in all of these is that it gets larger here, gets narrower in the pinched off part. So it's not going to be none of these because it's actually A. It is the voltage across the channel stays the same. And we can tell it not from the first picture that we were looking at, which was this one, because it's very, we can look at right here, it would go flat, but right here is where we can tell. Once our VDS is greater than our VOV, we are going to get this. And so that's how we would look at this problem.